So today we start with the Pelton turbine. Now the Pelton turbine is the only impulse turbine that we are using nowadays. Okay. Now this is also called a free jet turbine. We call it as free jet turbine because its jet is under working under its jet is working under atmospheric pressure. Okay. Now this is a high head turbine. So in this case, as we already seen, the head is more than 250 meters. Okay. And this is a low discharge turbine. So to run this turbine, we need less quantity of water as compared to other turbines. Now this is the basic diagram for Pelton turbine. Now if we want to see the various components of Pelton turbine, so those are, one is the penstock, okay, another one is the nozzle. Within the penstock, to control the discharge, we have spear. This is spear, okay. Another one is deflector. This is the runner. So on the runner, we have the buckets. So these all are the buckets which are mounted on the runner. Okay, this one is the casing. Okay. Now, to stop this turbine in case of emergency, we have another nozzle that we call as brake nozzle. Okay, that we call as brake nozzle, and water after striking the bucket goes to the tail race. So this is the tail race. So these are the various components of Pelton turbine. Now, if you want to see the working of this turbine, now the water from the reservoir is brought to the turbine through this penstock. Okay, so water comes to the turbine from head race or reservoir. Okay, through tunnel as well as then penstock. Okay. Now at the end of the penstock, we have this nozzle. Now the function of this nozzle is to convert whole available pressure energy of water into the kinetic energy. So that convert whole available pressure head into the kinetic head. So with the help of that, you got here a jet of very high velocity. Now this jet strikes on the bucket, which are mounted on the wheel or runner, that applies impulse. Okay, impulse or impact. So with the help of that impulse or impact, this runner starts rotating in this direction. With the help of this rotation of the runner, our shaft is also rotated. This shaft is rotated. So this shaft is further connected to alternator or generator that is used for producing the electricity. Okay, so that is used to produce mechanical power. Oh, sorry, used to produce electric power. So after striking the bucket, this water goes to the tail race. Okay, so you can see here the function of nozzle, that is to convert available pressure head into the kinetic head, and the maximum number of nozzle that we can use around the periphery of the runner, that are up to 6. Then we see different components of Pelton turbine. So the first component is the runner with bucket. Okay, that is this part, runner with this bucket. So that is the important part of Pelton turbine. Now, the runner of the Pelton turbine, that consists of the number of double cupped shaped buckets. So on the runner, we have mounted various buckets. So the shape of those buckets is of double cupped shape. So that are two cups that are joined together. Okay, when these two cups are joined together, there is a formation of sharp edge at the center. So that sharp edge we call as splitter. That sharp edge we call as splitter. So the jet which coming out from the nozzle is striking on this splitter and divided into two parts. Okay. Now this division of two parts helps in avoiding the unbalanced thrust on the shaft. This is the shaft on which this rotor is mounted. Okay. Now you can see how the bucket look like. This is the bucket, shape of the bucket. Okay. So you have two cups, one and two, joined together. This is the sharp edge. So at the center of this, the jet strikes. Okay. So this sharp edge we call as splitter. So when jet strikes at the splitter, so here you have the splitter, it divides into two parts. You can see in this diagram, it divides into two parts. Okay. So when it divides into two parts, so when division takes place, one part of jet goes along one side of the shaft, another part goes along another side of the shaft. So this avoids the unbalanced thrust, axial thrust on the shaft. Okay. So you can say the runner of a Pelton turbine consists of number of double cup shaped buckets that are fixed. So these buckets are fixed from this side to the runner. Okay. Now each bucket has a sharp edge at the center that we call as splitter. The jet strikes each bucket at this splitter and divided into two sides to avoid the unbalanced thrust. Okay. Now to get the full impact of striking water, when this jet strikes the splitter and divided into two parts, so this jet deflects back from this side. Okay. Now the impact is maximum when this deflection is of 180 degree. When this jet after deflection return back parallel to the coming jet, only then the impact is maximum. But there is disadvantage of this. When the deflection is 180 degree, what happen? This deflecting part of the jet strikes on the next incoming bucket. It strikes at the back of the next incoming bucket and produce disturbance. To avoid that, we make this angle of deflection to 160 degree to 170 degree. Okay, so that means we make this deflection at certain other angle that is like this. Okay, so this deflection is at 160 to 170 degree so that it goes out without striking the next coming bucket in front of the jet. Okay, now another thing you see at the end of the uh, bucket, there is one cutout. So this portion you can see over here, this we call as cutout. If this cutout is not there, you can see the each portion of the bucket is extruded out. It is coming out, and when jet strikes at the splitter, the water deflects back, does not comes back at equal angle at all the part of the bucket. At all these parts, the angle of deflection is not same. Okay, and another thing, when the jet, you can see jet strikes over here. When this bucket moves in forward direction, so jet comes out from this side. Okay, so here is some extruded part. If cutout is not there, so at this end there is some extruded part. So that also makes the deflection not at the same angle. Okay, so to avoid that, we provide a cutout. So this cutout solves two things. One, makes smooth entry. One thing is to make smooth entry of jet to next bucket. Okay, that is the one purpose that is solved by this cutout. And the second thing is the different angles of deflection. Due to this extruded part, if cutout is not there, when jet strikes, the water deflects back. So that deflection of water is at different angles. So when extruded part is not there, so this problem is again not there. Okay, so these two things are avoided by providing the cutout at the bottom of the bucket. Okay, then the material for the bucket, the material is cast iron. It is cast iron, cast steel, stainless steel, or bronze. Now to avoid or minimize the friction, the surfaces of this bucket is properly polished. Okay. Now how we mount these two buckets on the runner? So these buckets are mounted from this side on the runner. So that is either by casting or with the help of some fasteners. Okay. So with the help of fasteners, that may be nut and bolt. Now the advantage of this part over the casting is, now if there is any damage of single bucket on the runner, so if the fastening is with the help of nut and bolt, so you can easily replace that single bucket. Okay. Now if you have a casting runner, in that case you have to replace whole the runner in case of damage even of a single bucket. Okay, in that case you have to replace the complete runner. So that is the advantage of this fastener runner over the casting one. Now the another component is nozzle with guide mechanism. Okay. Now the function of the nozzle, as I earlier told you, to convert the available pressure energy into the high velocity energy in the form of the jet. Okay. Now the quantity of water required is proportional to the load on the turbine. Okay. The quantity is proportional to the load on the turbine. That means if the load on the turbine is high, you need more water to produce more power. In case load is low, you need low discharge. Okay. You need low discharge. So sometimes you need high discharge, sometimes you need low discharge. So to control that discharge, we use this guide mechanism. That is also called governing mechanism. So this governing or this guide mechanism is controlled, or you can say the discharge through the turbine is controlled with the help of a spear. So that we control with the help of spear. Now further, the movement of the spear is controlled by a servo mechanism. That is controlled by a servo mechanism. So that is a complete part of this governing mechanism. Okay. Now how the spear control the discharge? You can see in this diagram, when spear moves forward, so you can see the area of flow in the nozzle changes. Okay, so when that area of flow changes, so accordingly discharge changes. So when we move the spear in the forward direction, discharge decreases. When you move the spear in the backward direction, the area of flow increases. So therefore, the discharge increases. Then the material for the nozzle, the material is either cast steel or cast iron. Okay, or normally we can say the nozzle rings. Okay, and the tip of the spear that we made from some non-abrasive material. So non-abrasive material like stainless steel or bronze. So in case of damage, you can easily replace the nozzle ring or the tip of the spear. Okay, so that is the second component, the nozzle with guide mechanism. Third one is the casing. That is another important component. Now, as I told you earlier, now this casing does not perform any hydraulic function in case of impulse turbine. But however, we use the casing in case of the impulse or Pelton turbine. Now, the function of this is to avoid accidents because the speed of the runner is very high. Okay, so may some accident takes place. So to avoid that, we use this casing. Okay, then to avoid the splashing of water. Okay, the another function of the casing. This also leads water to tail race. The casing leads water. So when water coming out from the jet strikes with the bucket, so it direct the water to go to the tail race. Another function. And another is it also support the housing for the bearings. That is the bearing for the shafts. Okay. Also support the nozzle. Okay. So nozzle is also supported on the casing. Okay. Or you can also see the braking nozzle also supported on the casing. So these are the main functions of the casing that we use in Pelton turbine. Now the material for the casing is cast iron. The material for the casing is cast iron. Okay, so this is the basic of Pelton turbine. Okay, how this turbine works and the various components of the turbine, various components of the Pelton turbine. Okay, thank you.